So Citizen Data is a 5 years company located in Brest, West France. So I'm personally in Paris, but the company is the R&D team is in Brest. Yeah. Okay. And we have designed a solution named Warp10, which address time series data. And just to have an idea, who is familiar with time series? 3, 4, 5, 6. Okay, 7 maybe. So just to give you an idea of a time series. So time series is a technology to manage data from sensors. So we present generally in a global approach time series among these 4 different segments. And the first segment is what people usually knows in database, which is a relational database. And relational database are used to be dominant in the 2000 years, and to manage data from legacy application or for business application. And but during the 15 of 20 last years, other technology has emerged. Particularly NoSQL technology to manage data from social networks or documents of everything coming from internet, including songs and musics and video. But in that case, when we talk about big data, it's a big data as the technology relates to analytics of the content. The difference from time series comparing to SQL traditional relational database, it's in a traditional database the key data to arrange data relate to the business, to the content of the data. When in time series the data coming from the sensors. The key data to arrange the data is the timestamp. So all the data are arranged along the timestamp, and by doing that way, you are able to cross any source of data. So this technology, the time series technology in database is it's the technology in database that have the most important growth today. So in the next few years, we consider that comparing the volume of the data, the 2 dominant segments are going to be the NoSQL technology to manage the songs and the video, and the other is time series data stored in time series technologies. Today you have a lot of projects and people in which data from sensors and IoT are managed in a traditional database. But it's possible to manage this kind of data in legacy database, but there is no specific problem if you don't have so many data. But regarding the trend of IoT and sensors, most of the application design of this kind of application are supposed to change their technology in the next few years. If I try to... Okay. Just to understand the evolution, because the evolution is we have started to manage data from sensors, but we have projects, and what I have to say, we are totally editor. We are a software publisher. We don't provide any specific professional service. We are horizontal editor in time series technology. And we have started by managing data from sensors, but we have more and more demand for managing other kind of data. I would say any data related to an event. And if we, on this slide, it's just to have an overview of what happened in January in companies by managing data in a traditional database. So they have a business application, and all these business application manage their own database, I would say, in functional silos. And to develop interaction between all these silos, you have to face interoperability issues. And the dream, and people have worked a lot on that, is the semantic web. So by having a perfect, to meet a perfect interoperability, you would have to have interaction between all the data by having a kind of a global semantic web regarding the content of all the data. But we on our side, we consider that's a kind of a dream. And if you have, for example, in IoT, if you have a look on all startup, not only startup, but company working on IoT business, so they don't really care about standards. They develop their own objects with their own functions, but they don't really care about interoperability. If they use some basic standards, but they don't care about a whole interoperability like it is represented on the left of the picture. On our side, we don't care about a formal description of data. The only description of the data is not only a time description of the data, but time and location. Location when the location exists. So what we have developed is an architecture, which is a geo-time series architecture in which all the data can be defined by time and location. So you have today different, and specifically in open source, you have different architecture for time series, but the only geo-time series is the one we have developed. But today, for example, if we take the case of smart cities, and that's a kind of use case we work on, you have to cross more and more data. And historically, all this kind of data are managed by traditional system and traditional database. But if you consider all these topics, all these topics relate to elementary events. So we can consider that all what happened regarding all this infrastructure relate to elementary events. So for us, all of this is a time series. All of this. So by considering all of this with time series, we are able to cross anything, and we are not, by considering everything time series, for example, to understand there is an impact of what happened on one metro line, for example, on traffic or the opposite, for example. For us, it's just I would say mathematics or signal processing. We don't have to develop specific application in regarding a specific expertise in transport. It's just correlation or different techniques to aggregate different signals, different stream of data. So our technologies can be used for different kind of application, traffic optimization, service to citizen, energy, and so on. So you have different kind of application which are going to use this kind of technology. So behind this technology design at the origin for sensors, the evolution is to consider time series not only for sensors, but to any kind of elementary events. And for example, we have discussion with some companies. They consider in the future that everything is going to become a time series. I'm not going to give you the name of a famous company, but for example, if you consider a bank, his business is driven by your transaction, because a bank is the business of bank is to provide and to provide transactions. But if you take the industry, if you take utilities, telecommunications, everything is events. So you can you can consider that everything can be defined or store the data by using time series. So on our technology Warp10, we have designed a library of 800, a library with 800 functions, and we have developed our own language. So WarpScript is a language dedicated to time series. So most of data scientists, for example, use R or Python or language like that. But for example, to give you an idea, because it's totally dedicated to time series, WarpScript is going 1,000 times faster than R, or around 100 times faster than Python. So we provide these functions to applications, and that's a way to go faster in developing application. So we deal more and more with artificial intelligence, but we are not going to invent something in artificial intelligence. We take profit of our technology by using the scientific corpus of artificial intelligence, by mainly using tools like or library like TensorFlow or Torch or something like that. So just to be quick in describing the technology is made of two components. One is the storage component, and the other one is the analytics component. So the storage component is going to store any kind of data. So by describing a kind of raw data format with timestamp and the 3D dimensions. And we can store the data on HBase by using HBase, and we can store the data on standalone on-premise, and on any system that support a Java machine. So on a Raspberry Pi, for example, we are going to ingest, we are able to ingest 10,000 data points. Just to have an idea, we have some clients with today more than 500 billion measures a day. For example, OVH is a client. OVH manages all its own infrastructure by using Warp10. And we have the analytics component, and the analytics component is based on a WarpScript with 800 functions, and everything is sandboxes, so you can define some parameter to define your own limits or what some users are able to do. And by this language, we are able to, over the 800 function, we are able to deal with the different existing framework on the market. All these frameworks are adapted for some functions, but are not universal. For example, R and Python, even we are faster than R and Python. A lot of data scientists use R and Python. So we are able to ingest the development, what has been developed in R or Python. Or you can use Spark, but Spark is adapted for batch, but not for everything. So WarpScript is going to give you the ability to manage all this framework in a transparent way. So the analytics component obviously is going to work on our continuum storage engine, but it can work with any database. Generally, client has their own database, so we are going to plug our analytics engine on their own storage. So we can plug it on NoSQL. For example, we have discussion now with Oracle, because Oracle is interested maybe to use, or Microsoft as well, is interested to use this technology in their own framework, in their own architecture. So our value added is not in the visualization. When people ask us to make a demo, generally we refuse, because our value added is the engine. It's not in the visualization. For the visualization, we use existing component available on the market. So that I've gave you a word of that. So that's it.